Understanding JWT properly and using it effectively is a must to create secure backend APIs. Let's explore JWT in detail in this video. Technically, JWT is just a token format. The real story is to understand the structure and purpose of JWT and the role of JWT in authentication flows, identity management, authorization decisions, and secure verifiable transmission of access control and related data. Before we explore JWT in detail, let's brush up some of the key topics in security. Authentication versus authorization. First, we need to clear up one important thing. Authentication and authorization are not the same. Authentication means proving who you are. For example, you use your username and password, OTP login, single sign-on using Google, Microsoft, etc. for authentication. The backend verifies your credentials and says, okay, this user is valid. Authorization is different. Authorization means what you are allowed to do. For example, can this user access admin APIs? Can they delete resources? Can they view certain data? That's authorization. So where does JWT fit? This is where many programmers get confused. JWT or JWT itself is neither authentication nor authorization. JWT is simply a signed token format used to carry claims. Usually, the claims are user ID, roles, permission, expiration details, and so on. That's all JWT really is. Before JWT, session authentication was very popular. Many applications use session-based authentication, and many applications still do. Let's look at the session flow. The user logs in using username and password. The server then verifies the credentials, and that's authentication. If the user is valid, then the server creates a session and stores the user data against a session ID, and this session is stored on the server. After this, server sets a session cookie and is sent to the browser. The browser then sends that cookie back for every future request it makes. Server can easily validate the cookie, and using session ID in the cookie, it can retrieve all information stored in that session on the server. The server always knows who the user is, whether the session is valid, when the session is going to expire. All this information is with the server at all times. And invalidating sessions is very easy. Just delete the session ID from the server and that's it. But there is a big problem, the scaling problem. The things become more complicated at scale when there are multiple servers handling the API requests. Imagine backend servers, say server 1, server 2, server 3, all serving the same API. What happens if the user logs in to the server 1? The session is created on server 1, right? But the next request reaches server 2. That server may not know anything about the session, and this is a problem. Now we need complex solutions like shared session storage, sticky sessions, external caches to store sessions, session synchronization between servers, and so on. This increases the complexity, scalability, and this will increase the response time. So now let's look at JWT. Instead of storing authentication state on the server, the state is carried inside the token itself. With JWT, the backend becomes stateless. The server does not need to remember logged in users between requests. The token itself contains the necessary information. No need to maintain any stateful session in the server, and thus avoids the problem of complex session management. JWT is the gold standard used in microservices APIs. Now let's look at the information flow. The browser sends this token in every request as an HTTP header. If the token is valid and is not expired, the server accepts the token and uses the information inside the token to make access control decisions. Server verifies the signature using the private key and conclude that the token is not tampered and is issued by the trusted provider. So this is how the JWT flow works. Now let's look at the JWT structure. It consists of three parts and these are separated by a dot. So the three parts are header, payload and signature. The header typically has two parts: the type of the token, which is JWT, and the signing algorithm being used, such as HMAC, SHA-256 or RSA. This JSON is base 64 encoded to form the first part of the JWT. The second part of the token is the payload containing claims. The claims are statements about an entity, typically the user, and any additional data. For example, a claim may contain subject, which is the user ID, the roles that this user is assigned, and any other data such as username, expiration time, or any other custom information. So you should note that JWT payloads are not encrypted by default. They are only base 64 encoded. So anyone holding the token can read the payload. Never store sensitive data inside JWT. Now let's look at the third part, the signature. The server signs the token using a secret key. If somebody modifies the payload, the signature validation fails. Let's now put everything together. User logs in, the user sends username password, the backend verifies credentials. That's his authentication. After successful authentication, the server creates a JWT containing claims. This base 64 encoded claim is returned to the client. The client receives the token and stores it somewhere. Usual storage options are memory, cookies, local storage, and this depends on the architecture. Whenever the user wants to access a protected resource, the user agent sends the JWT, typically in the authorization header. The content of the header should look like the following: authorization and bearer and the token. After receiving the token, the backend validates the signature, expiration, and the claims in the token. If the claims are valid and it contains the roles, necessary roles to access the resources, then that access to the resource is granted by the server. Now let's look at some key facts. The JWT itself did not authenticate the user. Authentication already happened during login. The JWT is simply helping maintain authenticated state in a stateless system. Once the backend extracts the claim, for example, roles, the authorization decisions can happen. For example, admin can delete users and admin can view certain resources that a normal user cannot view. So those decisions are made using the role inside the claims. So JWT often carries authorization information. Why JWT scales well? This approach scales nicely because any backend server can validate the token independently. No centralized session lookup required. That is why JWT is heavily used in APIs, mobile backends, microservices, and distributed systems. Let's now look at the difference between access tokens and refresh tokens. Access tokens are usually short-lived and they are used to prove the identity and whether the user has necessary permissions to access the protected resource. Usually an access token is set to expire in a short duration, typically 10 minutes to 30 minutes. This is to minimize the security risk associated with hackers copying and using the access token. If stolen, the damage window stays limited, as we are keeping the expiry duration very short. When access token expires, the user needs to log in again to get a new access token. This is problematic as access token expiry is set to a shorter duration due to security constraints. The refresh token is used to avoid forcing users to log in repeatedly. When the access token expires or just about to expire, the client uses the refresh token and it exchanges the refresh token with the server to get a new access token. This improves both security and user experience. In a typical scenario, the server sends both the access token and the refresh token once the authentication is successful. When the access token is about to expire, the client exchanges the refresh token for a new access token. Common JWT misconceptions. Let's quickly clear up some common misconceptions. So the first one, JWT is automatically secure. No, JWT security still depends on HTTPS, secure storage, expiration policies, and proper validation. Without this, we cannot say that JWT is automatically secure. The second one is JWT replaces sessions completely. It's not always. For many traditional web applications, sessions are still perfectly fine. JWT payloads are encrypted. Again, they are usually only encoded, typically base 64 encoded. They are not encrypted. So let's look at where JWT makes sense. JWT works very well for APIs, single page applications, mobile apps, distributed systems, microservices. Basically, situations where stateless authentication is beneficial, go for JWT. Alright, that's it for this video. If you found this useful, subscribe more for more backend engineering content. Thank you and see you in the next video.